Kenapa? The same motor have can drive different loads, and different loads have different torque speed characteristic. Okay, fan sometimes it didn't have specification, or apa tu, dia punya speed tak sama macam blower. So when this motor connected to fan, we have to adjust the load, or adjust the speed or control the speed to meet the specification of the fan. Kalau connected to the blower, kita adjust pula the speed. Okay, that's why the speed control is very important. Okay, because different loads will have different torque speed characteristic. Boleh faham? Okay, so this is the torque speed characteristic for the induction motor. Okay, so kita dah belajar semalam, kita ada synchronous speed here. Synchronous speed. Okay, and this synchronous speed depends on the frequency and also the number of pole for the motor. And we have also pull out torques, okay, which is the maximum torque, and this will give your maximum speed. And this is a starting torque. At starting torque, the speed is equal to 0. And also nanti you akan ada macam the rated torque. You have to calculate like the rated torque, and the rated speed will be given here nanti. Okay, rated. Okay, so if we have like a load, kita dah belajar last time, the load, and this is the speed, the torque for the motor, and this is the load torque. Okay, the operation point of this motor and the load is at this point. Okay, the operation where they intersect each other. Okay, so katalah ini at speed of omega m lah, the operation. Okay, but what if the load must be operated at here? If the load, this is this is the same load, but we want to slow the load. Okay, macam kipas kita ada number 1, 2, 3 to control the speed of the fan. Let's say this is the speed when the fan is at number 3, and now we want to reduce the speed of the fan here. So what must we do? Takkan kita nak change the motor, right? We can change the torque speed characteristic of the motor by moving to this point. So kita akan move this like that. Okay, so this torque speed characteristic of the motor can be moved upwards or downward, left or right, okay, based on the control strategy. Okay, it can be moving here or it can be moving here. Okay, tengok control strategy. Let's say this is the rated speed. Kalau below the rated speed, you have control strategy to vary the speed. Kalau larger than the rated speed pun you ada a control strategy. So control strategy is needed to operate the load at different speeds. Okay, the same load at different speed, or kita boleh guna juga another load to control the speed. Kita kena control speed lah. Okay, so that's why we need the control of the induction motor. Macam DC motor, kita ada control of the DC motor, two strategies, VA control and flux control. Kat sini pun kita tengok how many strategies we have. Okay. So in control strategy for the in speed control strategy for the induction motor, we will be using the scalar control. What is the scalar control? Okay, it is based on the steady state model, but means we can only change the magnitude of the voltage and the frequency. Kita akan change the magnitude, okay, of the voltage and the frequency. And we will analyze this in per phase equivalent circuit. Okay, kita ada V phase here and we have frequency. Alright. Okay, if we are given the speed control method, kita nak belajar, it based on this torque speed characteristic. Okay, we have the torque here given by this equation. In order to control the speed, kita boleh ubah sama ada voltage, the amplitude of the voltage, the phase voltage, means the voltage given to the motor. And another method is we change or vary the frequency. So two methods in induction motor to vary the speed of the induction motor. The first one by varying the phase voltage. Okay. And the second one by varying the line frequency. Okay, tengoklah line frequency dia ada relationship with the speed and also the voltage pun ada relationship with the speed. Okay. And the speed control can also be achieved by the changing the number of poles, but this is not practical because we have the motor from the factory. We're not going to change the number of pole. Okay. And we also can vary the rotor resistance R2 in one rotor type, but it's not very recommended to vary R2 or to increase R2. Why? Kenapa not recommended? Okay. Kita ada satu macam DC control itu ada juga kan. Kita boleh letakkan resistance in between. Tapi why varying resistance is not recommended? Kenapa ya? Because it can increase the losses in the motor. So there are two types ni. First, varying the voltage, phase voltage, and the second one is varying the frequency. Okay, frequency of the motor. Okay. So these are the two methods that we will focus more, okay, for the induction motor. Boleh sampai sini? Boleh. So this equation is based on the per phase equivalent circuit tadi. Kita ada R2S. S ni kita dah belajar how to calculate S based on the speed. R2, R1, X1, S2 is based on the information given. Okay. So the first control method is variable voltage amplitude with constant frequency control. So you have variable voltage, constant frequency. It will vary the voltage, but the frequency kept constant. All right. So let's look at. Okay. So how to control or how to use this method? The first one is by using the transformer, but this is rarely used in order to vary the voltage. Yang commonly used is thyristor voltage controller. Okay, we have the thyristor here, the motor, and this thyristor voltage controller are connected to three-phase supply, and it is connected in anti-parallel with motor, either star or delta connection. Okay, it can be either star or delta connection. So kalau star or delta connection, V phase terus equal to V line ya. Kalau Y connection, okay, V phase equal to V line over √3. Betul kan macam ni? So voltage is varied by controlling the firing angle of the thyristor. Okay, we are not going into the power electronics, but kita kena tahu bahawa this can be done, the variable voltage can be done by connecting the thyristor in between the power line and the motor. Alright, it can be in delta or Y connected. Boleh? And these thyristors also can be used for soft starter of the motor. Katalah motor nak start from the rest, it can be a soft starter. And this operation only for quadrant 1 and quadrant 3. Okay, but we are more focusing on quadrant 1. Alright. Okay, macam mana cara dia berfungsi? How to apply this? Okay, what will happen? First of all, you must know that the voltage control, it can be varies between 0 to VT rated. Ini sama saja macam VA control in your DC kan? VA control pun sama. It can varies from 0, in between 0 to VT rated only. The maximum voltage you can vary is VT rated. And the operation is the below base speed or below rated speed operation. Okay. And based on this equation, if we change the magnitude of V phase, we also impact the torque. because torque is proportional to V phase squared. Okay. So kalau you varies the voltage, torque pun akan berubah. So kalau you increase voltage increase, torque pun akan increase. But when you reduce the voltage, torque and speed also will be reduced. Okay. So this is how, let's say you have V1. First you have V1, voltage. When you reduce voltage, okay, ini V1, this is the torque, and this is your load. Okay. First, katalah load nak operate at this speed. Okay. Higher speed, 1750. So, you apply V1 and it operate at this speed. Then you want to slow down the load. When you want to slow down the fan, katakan. So, you reduce V2 and your load, this is the operating point where the torque speed characteristic for the motor and load intersect each other. So you reduce the speed. When you reduce V2, okay, torque also will be reduced. Speed also kat sini tadi. Oh, sorry. Torque sini reduce. Speed pun reduce kan? Kata nak reduce lagi the speed of the fan. Okay. You reduce the voltage and the torque also reduce. The speed pun reduce. Okay. This is how you control the speed of the motor by using the variable voltage constant frequency. Okay, the frequency is kept constant. And if you can see the range of operation, kalau kita tengok kat sini, it's very small range because the slope for this type of motor is very steep. So dia tak boleh, kita nak operate at linear slope saja ya. Kalau kita masuk dekat non-linear slope, the operation will be less efficient. So the slope is very steep, then the speed range also very small. So for class B motor yang ada steep punya linear part ni, dia ada limited speed range. So is this type of control very suitable for class D. Class D yang ada besar dia punya linear part ni kan. Hence it's used on low power motor. Low power means speed also cannot be high lah. And efficient is not important, such as small fans or pump drive. Alright, so what we can see here, by reducing the voltage, okay, the torque akan reduce, the speed pun akan reduce. Alright, so the voltage can be varies. The highest voltage will be a rated voltage lah. It can be varies from 0 to VT rated. And the speed kalau tengok for class B ni dia from 1500 to 1750 saja. Okay, very limited speed. Okay. Boleh tak sampai sini? Boleh So the same motor, by controlling the voltage, you can vary the speed. Okay, dan dia punya apa tu? Torque speed characteristic pun akan berubah. It will moving to your left. Okay, will be below the rated speed. Boleh sampai sini? Okay.
Boleh, Doktor.
Alright, thank you. So this is the comparison for variable voltage amplitude with constant frequency control. Okay, katakan kita dah belajar yesterday. Kelas A, B, C, D. Tengok kelas D ni dia punya linear part dia very large. So it's limited to class B, which is low slip motor. Class B dia very limited. The speed range dia very small. But for class D, high slip, dia boleh sampai ke sini So dia punya speed range dia lagi besar. Alright. So this is how the variable voltage amplitude works. Okay. Okay, ni dah. Okay. Let's do one example for this type of control. Example dia, soalan dia sama je. But dia punya apa yang kita nak cari tu je beza, okay? So we have a 450 Hz, 4 pole, 1370 RPM. Delta connected, yes? Any question? Tak ada. Okay, and these are the parameters. Make sure ada R1, R2, X1, X2, and XM. And now the motor is used to drive an industrial fan with the load equation. Ini dia load equation. The drive was designed such that the motor load runs at rated motor speed when rated voltage and rated frequency is supplied to the motor. Faham ya? So, when you apply VA rated, F rated, you will get omega M rated. Okay. Now, the question asks you to determine the required motor terminal voltage, which is VT, and torque, TE, to drive the fan at a speed of 1200 RPM. Okay. So, mula kena fahamkan dulu. Okay, what is the rated, the rated speed here? Sorry, what is the rated speed?
1370.
1370 RPM. And we have the operation speed is 1200 RPM. So, omega M ni is less than omega M rated. That's why we will choose variable voltage.
VA control.
Yes, dia VA control for DC. Ini kita guna terminal voltage. So, variable voltage, constant frequency. Alright. Dia lebih kurang sama dengan VA control in DC. Lebih kurang sama. For below base speed operation. So, let's do it together. So, kita ada motor. Kita ada AC supply. AC supply motor, which is induction motor, to drive a fan here. So, VT rated dia berapa? 400. F rated dia berapa?
50.
50 Hz. Okay. Ada yang dah buat dah? Ada yang dah try dah semalam? Tak ada lagi So, because omega M yang omega operating ni is less than omega M rated, so we choose here voltage variable. Okay. Kita nak test your understanding, kita kena buat more practice problem. So, kalau voltage variable, apa range yang kita boleh varies the voltage? 0 to VT ni? Yes, VT rated. And what we keep constant? F constant kan?
Betul.
At F rated. Okay. So, ini information yang you kena faham. You must understand this information. Okay, because the speed is this one, the speed is 1200 RPM. It's less than 1370 RPM, which is the rated speed. So, in order to control this speed of the motor, we use voltage variable, where this voltage can be varies between V0 to the rated voltage. Okay? And the frequency is kept constant. So, now, apa yang kita nak buat? VT, kita dah dapat VT equal to 400 because it is delta connected. This is your VT. Frequency is 50 Hz. Okay, at steady state. So, kita kata, ini bukan omega, NM lah ni. NM rated. Okay, sorry. Okay, because it's in RPM. So, NM rated equal to 1370. So, macam mana kita nak start? Apa kita nak cari dulu? Dia nak cari V. Dia nak cari torque at 1200. So, apa yang kita nak buat sekarang? Kita dah ada rated torque ke belum? What is T rated?
Dah.
Mana dia?
Belum.
How to do this?
Key in formula.
Ya ke? At T rated must be at 1370 RPM kan? Okay.
Betul.
So, jom kita cari T rated. Masukkan dalam formula. All the information dah dapat. Ke kita dah cari semalam? Belum kan? So, TE rated kita kena ada B phase dah ada slip berapa? Omega S berapa? Sebelum masukkan tu, first we must find S rated. Apa formula S rated? NS minus NM over NS. Okay, all at rated condition. Tapi synchronous speed berapa?
1500 RPM.
Macam mana kira?
120 darab 5 bagi 4.
Okay, 120 F over pi dapat 1500 RPM. Semalam kita dah kira kan? So ini NS ni kita dah kira juga semalam. Berapa dapat? 15 at rated. Tolak 1370 over 1500 kan?
0.087.
0.087. Okay, boleh ke sampai sini? Semua okay ke? Before we find T rated, we must find S and omega S. Omega S is your synchronous speed. S is the slip. Okay, slip at rated. So sekarang kita boleh masukkan dalam formula ya. Jom buat. Ke kita dah kira semalam? Tak apa, kita buat lagi. 3 darab 400 squared. 5 over 0.087 over 1500 times 2 pi over 60 plus 2 plus 5 0.087 squared plus 5 plus 5 okay, squared. Okay. So in order to find T rated, you must find S rated and the synchronous speed to put in this formula. Okay, what do you get? Berapa dapat ni? Kita dah kira semalam. So TE rated equal to 48.29 Newton meter. Boleh sampai sini? Okay, now you already got your T rated. Okay? Dapat? Dapat tak? Boleh
Ya,
saya
nak salin.
okey, salin. Okey, ini baru rated ya. All at rated condition.
Okay.
Okay. So next. Okay, this motor is used to drive. Okay, to drive the load with this load torque characteristic. Okay, kita ingat kan, kita ada motor. And this is your induction motor. And maybe this is your load. Yang akan intersect kat sini. So this is your TL. This is your TE. Alright. So dia nak cari. Okay, berapa speed kat sini? Based on this graph. Speed kat sini, is it given? Kalau the motor is used to run the fan at this speed, the speed of the motor and the fan must be the same, right? So the speed is here is 1200. Ingat tak kita belajar masa DC? DC motor kot, ya. Electric drive tu. Okay, speed kat sini 1200. And macam mana kita nak, ini kita panggil apa? Steady state operation ya. Okay, what happened at this steady state operation?
TE equals to TL.
Okay, at this steady state operation, okay, TE, magnitude of TE equal to magnitude of TL, where TL equal to K omega M squared. Alright, but what is the value of K? How to get this value of K? Kalau at rated, berapa K? Kita dah ada value tadi TE rated kan? This one, TE rated. And if we have TE rated, we can come out with the value of K. Sebab K ni akan sama je lah. Okay. So, kalau kita nak tahu value of K, kita kena tahu value of TL. But at steady state, TE equal to TL. So, rearranging this, kita boleh cakap K equal to TL over omega M squared. Where at rated, TE rated, sekarang kena find K equal to omega M rated squared. Okay? Jadi, TE rated, we already get 48.29. What is omega rated? Omega M rated. Berapa? 1370 times 2 pi.
Over 60.
So what do you get for your K? Okay, what do you get for your K?
0.002.
Okay, kalau kita, yang saya dapat 2.35 times 10 to the minus 3 kan? 0.00235, right? Betul?
Betul.
So, to drive a fan at 1200 RPM, okay, kita ada TE equal to TL, which is equal to K omega M squared. Okay. So, berapa kita nak calculate torque sekarang ni? Torque. Berapa torque of the motor tu? By using this formula. So, K equal to 2.35 times 10 to the minus 3. Okay, what is the omega? What is the speed? 1200 kan? 1200 times 2 pi over 60. Okay. So, you will get your torque equal to 37.11 Newton meter. Okay. So, this is your torque to drive the load at the speed of 1200 RPM. Okay. First of all, you must calculate all the rated values. Lepas tu baru you put based on the equation for the load to find the new torque at the steady state operation. At steady state operation, TE will be equal to TL. Alright? Now, dah dapat torque, how to find the voltage pula? Sekejap . Sekejap. Saya nak copy satu lagi kat sini. Okay, how to find your voltage pula? Okay, you already got the torque based on TE equal to TL. Now, you want to find the terminal voltage. What is the terminal voltage? Macam mana? So now you assume F is at F rated equal to 50 Hz. Kan? Tak berubah. Only V yang akan berubah. So omega S equal to omega S rated. Kalau omega S rated equal to 1500. This is unit speed. Over 2 pi times 60. Okay, this is your rated value. Okay, so at the speed of Nm 1200 RPM. Dalam formula ni, ada apa-apa yang akan berubah tak?
Torque.
Sebelum torque, kita nak kira torque, kita kena ada slip. Slip berubah tak? Previously,
Berubah.
ah,
1,500 tak nak 1,200.
yes. Previously, you calculate the slip, but this is the slip at rated condition. So, at rated condition, you ada synchronous speed. Synchronous speed takkan berubah kalau frekuensi tak berubah kan? But this speed is at rated speed, 1370. So, now, because you want to calculate the voltage, okay, the voltage kat sini, you had the value of slip here. Okay, so you have to calculate new slip. Okay, so new slip S, new, will be equal to NS minus NM, okay, over NS. Yang ni 1,500 minus the new operational speed 1,200 over 1,500. Okay, so what do you get?
0.2.
Slip. Yes, new slip is 0.2. So in order to calculate the new voltage, we'll be using this new slip. Okay, based on the new speed ni. Okay. Now, kita nak rearranging this formula. Kita nak dapatkan, kita nak calculate for V phase. Okay, kalau kita arrange the formula, saya terus tulis nanti you try to rearrange sendiri. Kita akan dapat omega S, TE ni kita dah calculate tadi at steady state. Okay, R1 plus R2 over S squared plus X1 plus X2 squared over semua kan tak ni kan 3R, you please check juga S. Okay, so rearranging the formula, this formula, so we get this equation to calculate your voltage V phase. So boleh tolong calculate. What do you get? Semua dah dapat omega S, this one. Make sure you change to radian per second. The new slip is this one. Okay. So the torque tadi you dah dapat. Maknanya kena cari torque dulu baru boleh cari V phase. The terminal voltage. What do you get? Dah dapat dah? So answer dia V phase, cuba kira kira sendiri baru kita ada experience on how to solve this question. Okay, dapat 253.84. Okay. Terminal voltage. Kalau dia kata terminal voltage, is it V phase or V line? Anybody?
V line.
Yes, V line. Okay, kalau dia kata terminal voltage, dia V line. So, V phase ni yang kita dapat ni, is it terminal voltage?
Yes, sebab delta.
Terminal voltage? Is it terminal voltage? Yes, because it is delta connection Delta connection. What if katakanlah dia Y connected? How to find your V line? Kalau Y connected, yes, to find your V line, you must times √3 times by V phase. Okay, sebab yang kita calculate ni ialah V phase. Ingat tu Boleh? Okay, so because this is delta connected, V terminal equal to V phase. Kalau Y connected, V terminal equal to √3 times V phase. Boleh? So let's look at the answer. Kita analyse sikit the answer. Previously, PT is 400 volt and it gives the speed of 1,370 and the rated torque tadi berapa? Rated torque TE rated dalam 48.29. Okay. But this time when we reduce the speed, kita nak reduce the speed, we can see that the voltage now is lower than the rated voltage. So the voltage lower, the speed pun also akan reduce, and the value of torque tadi pun, previously kita tengok torque dia yang kita dah calculate 37.11, the torque also reduce. Okay, so by reducing the speed, we have to reduce the voltage, and the speed will go down, and the value of torque also will be reduced. Okay, that is the voltage, variable voltage with constant frequency. We didn't change any frequency. It's fixed at the rated frequency. Boleh tak? And this operation or this control is for the speed below the rated speed, and we can control the voltage between 0 to VT rated. Boleh sampai sini? Any question? Ada soalan tak? Any question? Ada? Tak ada soalan
Tak ada doktor. Setakat ni okey.
Okay. Setakat ni okey. So next, let's go into the second method, which is variable frequency constant voltage control. Kita tulis VF CV. Senang. Variable frequency constant voltage control. This is the second method to control the speed of the induction motor. Kalau previously variable voltage constant frequency, the speed is below the rated speed, and V is between 0 to V rated. Okay, then kali ni let's look at what happened this time. Okay, what will happen if we change the frequency, varies the value frequency with the constant voltage. Okay. And okay, for variable frequency with constant voltage control, we require the use of PWM inverters. Kita not going to go through the PWM inverters. We have learned this in Power E kan. So nak control the frequency, saya rasa ini lab number 3 kot. Guna PWM to control the frequency of the motor. And frequency will increase from the rated frequency. So frequency dia kita akan change higher than the rated frequency, and this will increase the speed of the motor. Okay, kita tengok sini. Okay, what will happen? Okay, so this is frequency, katalah frequency. Kat sini frequency mana satu frequency ni? Frequency go higher. Okay, kalau kita tengok stator voltage is held constant at the rated value. So VT equal to VT rated. Okay, this is in your, ada dalam nota kan? Dah buka nota dah? Ada print out nota. Okay, this is on the first diagram. Kita ada F1, ni saya lupa label lah ni. F1, katalah F1 ni ialah 60 Hz. Okay, kita label dia. Okay, this is F2. F3, F4, and F5. Okay. So the speed control, kita nak control the speed above the rated speed. Okay, this is operation for above the rated speed. And when we increase the frequency, okay, we increase the frequency is increased, the torque will decrease since TE is directly proportional to 1 over omega S. Omega S tadi tu apa dia punya formula? 120 F over P kan? So kalau apa tu frequency increase, speed pun increase. Kita tengok sini this is relationship. This is the relationship. Kalau speed increase, frequency increase, speed increase, but torque is directly proportional to 1 over omega S, the torque will be reduced. Boleh? Boleh nampak macam tu? Okay, so this is an example of frequency control, okay, or variable frequency. This is the talk speed at rated katalah 60 Hz. Okay, 60 Hz. Kalau kita tengok kat sini, okay, this is the omega s ataupun ns, the synchronous speed. Let's say the synchronous speed is 1800 RPM. Okay, if we decrease or if we increase the frequency, kita tengok the talk akan reduce, but now the synchronous frequency, the synchronous speed will be increasing based on this formula. Okay, and we have higher operational speed than F1. Nampak ya? Dia akan increase. This is a load torque. This is a motor torque TE yang ni. So we increase lagi frequency. By increasing the frequency lagi, the speed akan increase lagi. The synchronous speed akan increase. And the operational speed pun akan increase and so on. Okay, but in this example, all the torque will be reduced due to the increase of the speed. Boleh faham? Okay, based on this formula. Okay, pay attention for this frequency control, variable frequency ni sebab dia ada, it will change also the value of X1 and X2. Okay, kalau dekat variable voltage, R1, R2, X1, X2, SM semua akan constant because the frequency is not changing. But in this variable frequency, value dia akan berubah. Okay, cuba tengok kat mana. Okay, now for variable frequency, constant voltage, the new operating frequency is F new. So kalau F berubah, based on this equation, you will have the new synchronous speed. Boleh faham ni? Kalau frekuensi berubah, okay, you will have new synchronous speed. Jadi you akan kena calculate pula new synchronous speed. And this will also affect the calculation of slip. Macam mana slip tadi? Slip equal to NS kan? Minus NM over NS. So kat sini you have to calculate new slip lah. Based on new synchronous speed. Alright. And because the relationship of the inductor and the frequency, kalau ingat lagi, inductor, X equal to 2 pi F. Okay. X equal to 2 pi F. Therefore, the new stator leakage current, kita akan calculate X1 new and also X2 new based on the new frequency. Okay, macam mana nak calculate X1 new? Is equal to KX1. This is the old reactance. And what link them is this equation. K equal to F new over F rated, where K must be greater than 1. So kalau you ada kena buat variable frequency with constant voltage control, you must make sure you calculate all these new values before you calculate the phase voltage. Okay. Kalau tidak, nanti you guna old values, akan jadi salah lah. So all these induction motor equations can be used with the modification above. Boleh faham sampai sini? Boleh Okay. So this is the difference between these two control methods. The first one, variable voltage, constant frequency control, where you can vary the voltage between 0 to the rated voltage. And this is suitable for below rated speed operation. At this point, the frequency is kept constant at rated frequency. And when you reduce the voltage from V1 to V2 to V3, you will reduce the torque and the speed also will be reduced. Okay, the operational speed is reducing from here. Okay, 1, 2, and 3. So the torque pun reduce sekarang tengok. The torque pun reduce. Okay, this is T1, T2, T3. So before you katakan you want to calculate the needed V phase, you must calculate your your torque. Yeah. So it limited speed for class B, and this VVCF, variable voltage, cannot be operating above base speed. Boleh sampai sini? Okay. So for frequency, variable frequency, constant voltage, the frequency will be increased higher than the rated frequency. Therefore, your motor will be operated higher than the speed, the rated speed, and VT is kept constant at rated value. And the speed control is for above rated speed. And the torque also will be reduced because this is the relationship. And it cannot operate below the base speed. Boleh faham sampai situ? Yang ni lebih kurang VA control lah dalam DC. Yang ni lebih kurang flux control lah. Kan? Above the rated speed. Any question up to here? Semua pun based on this equation. Ya? Any question? Boleh faham tak? Sempat tak kita nak buat satu lagi soalan ni? Okay, sempat lah. Faham Okay. So, we are going to do the same example just to enhance your understanding. Nanti you kena tengok balik juga. Okay, this time the same example, but this time kita nak the terminal voltage and the frequency to drive the speed at 1600 RPM. Okay, so kita tahu dia 1600 ni is greater than 1000, okay, and rated, okay, and M is greater than N rated. Therefore, kita akan guna variable frequency, constant voltage control. Okay, boleh? Boleh start? Tu macam mana? Apa nak buat dulu? Any idea? Cuba start. Okay. Kita dah calculate tadi. Because NM is greater than N rated, 1600 greater 130 RPM. So kita ada variable frequency, constant voltage. Okay, kita ada this formula. We want to calculate for motor terminal and frequency. Frequency. New frequency. Okay, kat sini berapa terminal voltage dia? Ada perubahan tak? VT?
Tak ada.
Tak ada. So, VT equal to 400. Ya? Lagi? Apa lagi yang kita dah dapat tadi? So, at rated, TE rated tadi kita dapat berapa? 48.29 Newton meter. And K juga kita dah dapat tadi. Oh tapi yalah at omega M rated. K tadi at rated. Berapa dapat?
2.35.
Okay, 2.35 times 10 to the minus 3. Okay, now we know that TL equal to K times omega 3 omega M squared kan. Now to run a fan at 1600 RPM is above the rated speed. So how to find the frequency? Kita tahu NS equal to 1120 F. Okay, how to find this frequency? Any idea? Any idea? Tak ada idea? Kita tengok balik formula mana yang kita nak guna. Okay. And S kena ada F new. Boleh cuba tak? Formula ni jugalah. Formula ni juga. Kita tak ada NS kan? NS tak tahu. Omega S tak tahu. V phase kita dah tahu. Sleep ni macam mana? TE kita dah tahu dah. Rated. Tak tahu. Tak ada idea. Okay, so this is your homework. Homework untuk buat and submit to me. Boleh tak? Saya kira ini sebagai quiz 4. Okay. So, example for this speed control variable frequency ada juga dalam video yang saya dah explain dalam video. Okay. So, for this one, I need you to do this homework and submit to me. Tomorrow boleh tak? Boleh tak? Boleh insyaAllah. So, saya tak nak bagi yang susah-susah lah as your quiz. Kita dah belajar dalam kelas. Cuma you must find how to do this je. Boleh tonton juga video, boleh watch the video on one of the example. Example 2 untuk variable frequency constant voltage. Then based on that video, you terus solve this question ya. Boleh? I think that's all for today. So we have finished the speed control. The first one is variable voltage constant frequency. The second one, kita go through into the theory of variable frequency, constant voltage. But I want you to to finish off this question and submit to me and take this as quiz 5 lah. Quiz 4 pun, quiz 5 ke quiz 4? Saya pun tak sempat tanda lagi, nanti saya tanda, saya bagi balik Alright? Boleh?
Doktor, soalan ni dia nak cari terminal voltage dengan frekuensi je.
Frekuensi. Frekuensi yang new frekuensi lah. Tapi okey, dengar sini Nak cari terminal voltage, first you must find the frequency. Macam tadilah dia cari torque dulu. Sorry. This is a new terminal voltage ni, dia based on, jangan lupa juga tukar this one. Okay, this one X1 new, X2 new ni. Ya, nanti you tengok video tu. I want you to give homework, maknanya watch the video on the example of variable frequency. Then you start doing this ya. Sebiji je macam video tu. Okay, nanti you have to change X1 new dengan X2 new juga. Okay, boleh? Boleh
Madam, yang ni hantar by 12 malam ni
Esok.
Alright.
Esok 12 malam nanti saya buat submission untuk dekat Brighton. Saya rasa saya bagi masa banyak lah tu. Okay. Saya tak nak awak semua nanti stres belajar. Mesin ni semua tak payah stres. Belajar enjoy aja. Homework pun saya bagi simple je. Mungkin assignment tu yang susah sikit. Yang lain semua okey je kan. Okay. Jangan stres, belajar rajin-rajin. Okay. Itu saja saya rasa for this today class. So see you insyaAllah on Thursday. Apa-apa saya akan update on what to watch and what to go through on Friday. On Thursday. On Wednesday. Kalau kita bukan test lagi kan minggu ni kan. Saya akan bagi tahu esok Okay, that's all. Thank you. Hope to see you on Thursday.
Thank you, madam.
Ya, test. Test akan masuk electric drive yang gears, translational motion semua tu kan. That one ada one question and satu lagi ialah rectifier, control rectifier for the DC motor. Okay. Yang choppers, induction motor semua akan masuk test 3 which is your final lah later. Alright. Dah dapat kan exam untuk jadual exam untuk final? Dah dapat ke belum?
Dah.
Dah. Okay, 24 bulan Lebih kurang lah macam tu. So please prepare for your test next week. Tengok balik dan kita akan go through, mungkin kita akan buat revision jugalah before kita pergi test on Friday Okay, thank you so much and see you on Thursday. Jangan lupa buat homework ni. Okay, bye. Assalamualaikum.
Thank you, Doktor.
Uh,
Hmm.